My name's Adam, and my plan for this time was to do some live coding and demoing of some of the latest features. I have a secret interest to get more people using IntelliJ, so I thought if you saw me use IntelliJ, you'd be like, whoa, you can do all that in IntelliJ? Yeah, maybe we could close the door, just lock it. Just kidding. And show off some of the newest features to see like what's possible. And I sort of want it to be interactive, so feel free to just jump in. It's sort of unstructured, so yeah. Raise your hand if you've ever used IntelliJ. All right, you guys know what I'm talking about. Okay, raise your hand if you've never used IntelliJ. All right, well, we'll see if we can get some converts. So raise your hand if you've ever cloned the Chisel template. Okay, so that's the best place to start if you want to do local development on Chisel. Maybe you've done the boot camp and you see, okay, I sort of get it, now I want to get my hands dirty with my own project. So that's what I did. I cloned Chisel template. So that's basically this. It's got a README, which describes how to start your own Chisel project. You can run, there's a little GCD as the toy example. You can run it, you see some stuff pass, and it worked. So great. So what I did was I did that, and then I started just creating some additional projects to play around with and to show some new features. So the first thing I wanted to show was intervals. I mentioned at the talk yesterday that there's a new data type called intervals. So I thought I'd just very quickly show sort of what that is. So normally, you know, you can declare something like I have some input port, and it is an I/O, it's an input, and it's like a uint with a width of 3, right? So uint is a data type with 3 bits. If I want, I can, is this big enough? People see it? Okay. If I want, I could sort of say, I'm not going to declare the width of this. It's an unsigned integer, but infer the width for me. And then Fertile will do the width inference and do things properly. So what we wanted to do was, actually, I don't know if you guys know, there's a fixed point type that was already in Chisel. And you can declare the width as well as like the number of binary points. So basically you have some, it's like 11-bit wires, but like 3 of the LSBs are representing like the fraction of an integer. And then here what we're doing is I'm saying I have some output and I want to infer what the width and the binary point are so that I don't lose any precision or any values. So I can do that. Here I have some number of constants, and I'm like, I don't know, I'm creating a fixed point value with, I'm saying 0 binary, of those are 0 binary points. I'm assigning them to a register, and then I'm folding left over it. So I'm just like continuing to accumulate this product. And then I'm assigning to my output. So I can run this. So this is SPT. Let's see if I have it somewhere. There it is. So if I run it, it should compile. Oh, look at that. Uninferred width. Yeah, because I declared this and then forgot to delete it. Thanks, Chisel. Oh, we cleaned up some of the stack traces. So, you know, in your thing, I was like, oh my God, miles and miles of stack traces. It's better now. So, good to go to the latest versions. So we're running it, and I can check out this intervals, and you're like, we inferred what the output of the fixed value should be. Okay. So that's great. Now I want to do. So what is intervals? Why is it cool? So instead of declaring like the width and number of precisions, I'm just going to declare a range. So since I have some a priori knowledge, I'm designing the circuit, I know I'm like sampling something, and I know that no value is ever going to be over 100. So I can declare this range, and I can say, okay, I know that, and also I care about like 3 bits of precision. I can declare that and then do all of my computation, my DSP computation of multiplying things, etc., and then assign to my output. Here I'm declaring all of these to be unknown, so I don't care what they are, but please do the inference for me, because it's sort of complicated and tedious to do it manually. I can then do a similar computation where I'm multiplying and adding things and whatever. This dot I is how to declare like an interval literal, and assign to my output. So here I do that, and it will infer all the things for me. Now, fixed point, because you only declare like the maximum number of bits you need, not all of these bits are used to, if I actually know my range is 0 to 100. And so these extra bits, or not even the bits, maybe all the bits are used, but not the full range of values that could be represented by the bits is used. So, but the just normal bit with inference doesn't know that, so it is very conservative. So when I generated this example, it generated a lot more extra bits because in the inference. If I know the values that they could be, I have a more bounded inference on all of the arithmetic operations, and so I can get out something that is significantly less width and thus have area savings. So that's what the interval type is. So it is an experimental. We added a few new operators, so you should check it out. You can give us feedback on it and let us know what you think.
Is the range is that a Scala thing, that range?
Yeah, so we actually wrote like a little macro so that this is to ease the expression of a range to make it like nicer. You can also, I'm pretty sure there's like a range object you could create explicitly, but this is the recommended way to do it.
Okay, and then the .3 is the number of bits of precision that you want?
Yeah, the .3 is the number of bits of precision. And if you want open or closed bounds, you can do that too. So like, suppose I wanted to, this is 0 through 1 with like 7 bits of precision, but I want it to be like almost 1, but not really. So you can actually do that where it's an open bound on the max or min value, and then it'll do the inference for you. And that's where this precision comes into play, where the closest value to 1 is you have to know what the precision is to do that, but it's it all is taken care of for you.
But there's something precision, and third precision.
Yeah.
You only see the development, right?
Right. So it all gets lowered to bits. So you don't know. So that is one feature request, which is actually to change the names of the signals to know what the precision is, so that it's easier to parse it. But as of right now, it just gets all lowered to bits, and
I mean, you have to infer the number of bits at the end.
Yes.
But you only see that verbal level or relevant level, right?
Yes.
I cannot access this
At
Chisel level.
So there is some. If the inference can be done in Chisel, it is being done under the hood. So if you are doing intermediate computations with the general problem is that we have wires and you can connect to them multiple times. And so the width and like values of that wire, if it's unknown, depends on multiple assignments. So we have to elaborate the whole module before we can actually know what the inference is. So in those cases, we have to wait until after Fertile starts and can do the inference. If it's just intermediate computations, then we can do the inference, and you can do pretty sure you can do out interval dot range and get out what the range is, if it can be done in Chisel. But otherwise, you have to wait. Yeah.
So this is static bit inference, right? If we have to put number. You say, right, if I were to extend this to some sort of profile-driven bit inference, say, for example, I have a closed system. I'm designing a closed system.
Yeah.
And the software is in my control. It's very involved. And so
yeah, I get what you're saying.
Chisel comes very handy. And if I have a configuration layer structure associated with this, I could have my profiling generate the configuration parameters and then regenerate using those.
Yeah, so I could do something like this, where like, right, so I'm making this parameterized, and I can stick these values in here. I think this works. I've actually literally never done this. Live demoing. That seems to work. Cool. And then I can do this with maybe more conservative numbers, profile, and then iterate, do that type of thing. We do have so that's like the bad answer. The good answer is Chisel supporting a profiling tool, which lets you sort of see the histogram bins of like this signal took these number of values over the course of the simulation, and then automatically prune the signal widths to minimize that. Something, right, that would, that sort of gets that, something like that. So actually in the deprecated fertile interpreter, we were doing that. We had a capability to do it. In fact, Chick was the one who did it. So the guy with the like long white hair and the goatee, he was working on that. And I don't know if he has ported it to Treadle yet. So if that's something you're interested in, then definitely talk to him, because everything is a matter of priority, and part of these conferences is to figure out what people care about. So if you want something like that, then yeah. Yeah. Cool. Any other questions?
How do you choose a profile?
So it's in the deprecated Treadle, or deprecated fertile interpreter.
Oh, okay.
So it's like,
Profile doesn't exist at all for Treadle.
I just don't know. So unfortunately, we'll have to just ask Chick. But he's helping run the boot camp right now. So okay, great. So I'm going to move on to something else. So the other thing I've been working on are aspects. They're called Chisel aspects, and it's a way to well, do I want to get there yet? Actually, before I get to that, I talked about the stage phase refactor in my talk yesterday. So I want to sort of give a little taste of what does this let you do to sort of customize your Chisel build flow. So I don't know if you noticed here, but I'm calling Chisel, when I ran this, I said run main, chisel3.stage.chiselmain, and I'm passing a command line option, intervals.interval example. Okay, and I can run this, I can run that, and it works. Oh, because I added parameters, again, me changing things. What was it, 100 and 0? Okay, so now this will work. Cool. So I'm going to now take, like, what? Uh-oh. It's looking good over here. Guys, it looks amazing. Really good. No, you can see. Okay. So that's I'm sort of specifying what the top level module is I want to elaborate. So it's just a command line argument. So here, I have gcd.gcd. And now I'm elaborating and generating the Verilog for my GCD. So let's say I took Albert's writing a fertile transform, and I want to add that fertile transform into my build flow. Seems some sort of straightforward. What you sort of had to do before, well, I guess, one option would be like to change the fertile source code to stick my transform in so that when Chisel calls fertile, it gets run, etc. But that's not very extendable because I want to just take someone else's code from the internet and just sort of change it with it on the command line. So we've added this .-fct, which stands for fertile custom transform. And then you can pass it the class name of your fertile transform. So I wrote a little fertile transform. What it does is it looks for, this will make more sense to later today. It looks for the source locator information, okay, of certain signals that I've specified. So like if it finds a certain like name, a signal with whose name is in this set of references, print out the source locator information. Okay, so let's change this. Let's just do it for registers. If it is a register, print out its source locator information. So now I'm going to add on the command line, where's the package? Transforms dot print source locators. Okay, so I printed out the source locators of the two registers in my GCD, and it got sort of added into the fertile compiler. I didn't have to change any main or anything. Okay? All right, so maybe you guys aren't impressed. That's fine. Don't worry about it. Okay. Now, what I said here is like all registers.
Lots of stages, right? What stage? You have these transforms in stages.
Right.
Where does this one go?
Ooh, good question. How does this know when to run? So we have this old API that specifies basically the form of the fertile that it should be expecting in the compiler. So the way the fertile compiler works, which will be talked about by Albert later, is there's like these stages of the compiler that are sort of rewriting more complicated nodes with simpler nodes. What I'm saying here is like when it's in the high form, run it. And it's not great because what if there's multiple high form ones? What's the order they get run? We really wanted some more fine-grained dependency API, which is something that we've added, but is still in the process of getting upstreamed because of annoying reasons that I don't want to get into. But it will soon be there. So I will be able to specify very discrete, or very, like with a scalpel, what's that word, exactly? Something like that. Precisely where in the compiler to inject this, okay? Cool. So I ran that, fine. Now, suppose I don't want to just print out the source locators of all registers. I want to specify some additional data, like print out the source locators of these specific signals. I need to somehow get that data into the transform so it knows what's due, okay? And that's why we use this annotation system. So what I did here was I created an annotation, which this reference target is Fertile's way of referring to signals in the design, okay? So if we can jump to, oh, whoa, what was that? That was IntelliJ. I can jump to declarations of things. That's cool. Use IntelliJ. Okay. So this is basically like a path into the circuit. I say it's a given circuit, a given module, optionally like a path in, and then a reference. So what I'm doing is creating this annotation. It's a single target annotation on a target, and you have to tell Fertile how to duplicate it. But other than that, that's all you need.
Notation is Scala thing or Chisel?
It's a Fertile thing. It's a Fertile annotation. Okay, so you can think about it as I'm annotating this signal to print out its source locators. In my Fertile transform, I'm going to look through the annotations, and this will actually be talked about more in Albert's talk as well. But basically, I can look through these annotations, find the ones I care about, and populate this set of names of the things I want to print. So we're going to now go back here and say, if, if basically it was in my annotations, now print it out. Okay? So that's great. We have a way to get data into my transform, and we can try and run it. And nothing prints because we never specified which signals to annotate. Okay? So now we've sort of set up in Fertile a way to get data, but we don't know how to generate data. So what I've added here is a Chisel API for specifying my ability to mark things. So what I'm doing here is saying, given some signal, annotate it with a Chisel annotation, which will later get converted to a Fertile annotation here with mark to print. So basically I'm saying, let's delete this for now. I'm saying create this mark to print annotation and stick it into the state of Chisel as it's collecting annotations to get passed along. Why is there a Chisel annotation versus a Fertile annotation? This is a quirk of the compiler, or of the system, unfortunately. When we are constructing Chisel, we don't know the names of everything, because when we create a signal and we give it a name, maybe it needs a temporary name, and that depends on, we have to generate the name, and maybe there's a conflict, so we have to uniquefy the name. So at the time when Chisel is constructing things, we don't know the name. After the module is elaborated, we then know the name. So there's this sort of two-stage thing where the Chisel has a reference to the actual data, but then this toFertile gets called after module elaboration, so we know what the actual name is. That's really the only difference. It's like a little indirection. So now if we go to my thing, I'm going to mark, say Y, and this will create that annotation. It gets propagated all the way through to my custom transform, and then it'll get consumed and print out. So now let's see if it works. It works. We printed out the source locator of Y. Okay. So are you seeing how we're sort of customizing the compiler here? Or am I like totally losing everyone?
So adding compiler code to your circuit, so to say, mixing up the compiler with the circuit itself.
I'm sort of linking them. I'm saying I'm generating the data for metadata or annotating things or whatever, and I'm letting myself consume it later in the compiler when I can do a full compiler transform. I can walk the whole AST. I can, I have a lot more power in Fertile. So it's a way of like linking the two the nice thing is if I write a nice Chisel library and I expose some like very nice user-facing API, I can just publish it and people can now start to use it because maybe someone makes a really cool like, I guess print source locators. I don't know, something that's more generally useful. You can just include it in your workflow, and you don't need to like upstream it to Fertile or upstream it to Chisel or anything. It enables building these additional libraries. Okay, so we've marked it, and we said run our custom Fertile transform, and we're done. Now, if the question is, well, what if I don't want to force someone to change their main to use my API? I sort of want this to be enough to customize everything. Does that sort of make sense that I don't want to have to, I maybe want to run it or not? So there's another thing we can do, which is what I had here before, which is I'm going to create two annotations when I run this API. I'm going to have that marking one, but the second one is a run Fertile transform annotation, okay? Which basically says when Fertile is trying to decide what to run, it looks for this annotation for any custom transforms that you want to run, and we'll schedule them, okay? All right. So in this mark, I'm telling Fertile, run my transform and annotate this signal. So now if we run it with just that change, now our transform gets run. That's cool.
What stage now, because now,
What stage does it get run?
yeah, now you don't specify, right, anywhere.
Oh, so this defines when it gets run.
Oh, that is still there, okay.
Yeah, it's just that transform. Okay?
The previous time had a minus whatever, F something.
This FCT. Okay, now, maybe you're more impressed, maybe not, I don't know. But,
With all of the question, how can I avoid it?
how can you avoid the dash FCT?
Yes, sir.
Yeah,
Okay.
right, you can. So that's the thing, command line options are annotations, okay? They're just an API for generating annotations to a stage. So what this FCT does is nothing other than generate this, this run fertile transform annotation with this thing. Okay, so it's using the same underlying core mechanism to support all of this. Okay, so it means there's one way to sort of tell Fertile how to do something, but we've exposed different APIs for different use cases. Okay, and it's all extensible.
So is it more than enough to kind of combine them if I have multiple, marks in the code?
Yeah, so this will, that's where the dependency scheduling thing comes into play. So if you run it, it's saying it to run this transform, and so it will, if it has multiple commands to run it, it'll only run it once.
So do you not need to define that case class among the print if you're just planning to use the top annotate style? Use it within.
So yeah, so the annotation is like the messenger, right? It's the thing that in Chisel it gets generated and it gets passed along through Fertile and eventually can get consumed by the transform. So it's like the messenger and it needs to be defined. But this is like, you can see I'm doing all of this in one file. I don't need to touch Chisel or Fertile. I'm just purely extending it here. All right. So we've had a few ways to like turn on transforms through the command line interface, through maybe a Chisel API. But now there's this thing called Chisel aspects. What is that? I got 15 minutes. So the idea behind it was, suppose this isn't my code. This someone else wrote, the best GCD ever, and I would just want to import it as a jar. I don't want to have to change its source code. I just want to reuse it. But man, I really want to use my cool source locator library. How do I do that? Because right now, the only way to sort of specify signals is by changing the Chisel source code. Okay? So what we've added is another way to annotate signals that's not in a Chisel elaboration. Okay? So there's one stage which is Chisel elaboration, this thing gets called, and then a second stage called an aspect stage, which is given the elaborated thing, annotate stuff. Okay? So you can see how it plugs in, and it just takes those annotations, sticks them in the same mechanism, and we go. So what I wrote here, this is the file it keeps on giving, is a mark to print aspect. Okay? What it lets me do is provide a function. This is the API to the user, which is given my design, pick some signals to mark. That's all that API is, okay? And then this is how we are implementing that API. We're going to extend aspect, and we only have to overwrite one function, which is given the top, this elaborated Chisel design, return annotations. That's all it does. So what we'll do is we're going to call that user function to get the signals. We are going to then create all the annotations we want. We can directly call this to target because we know the names. We don't have to do that whole Chisel to Fertile thing because it's already elaborated. We know the names. And then once I have all those marked to print source locator things, I'm going to append on a run Fertile transform annotation of print source locators. So I'm generating the same annotations and run thing in this mechanism, but it's separate from my Chisel design. Okay? So now let's see, yep. So now what I'm going to do in my design, I've imported this GCD. I'm not touching the source code, but I want to annotate some stuff. So what I did is I extended my mark to print, this person who, other Adam who wrote this mark to print aspect, this library. I'm going to extend it and provide my function, which is given this GCD that you've elaborated, pick the signals I want to annotate or to mark to print. And that's all it is. All right, so I've created it. How does it link into the rest of the Chisel? Well, you maybe have guessed it, but this is nothing more than a command line option. Maybe you didn't guess it. I don't know. Did you guess it? I'm going to elaborate my module GCD, but I'm going to say with aspect, what package is this in? gcd.aspects.gcd mark signals. I run it. It marked these two, and we printed the source locators for those two things. Okay? So this lets me basically import other people's code, use it, but I can introspect on it. I can use the power of Fertile to do whatever the heck I want under the hood and trigger annotations in this way. Okay, so are there any questions about this?
Can you show me that with aspects, the actual command you ran just now?
Yep. With aspect, this actually I need to upstream. So, but I was making this demo. I was like, man, I wish there was like a dash dash for the aspect. So I added it. Okay.
Why is it dash FCT but dash dash?
So the short version of a command is one dash, and then it's like random garble of letters that stand for things.
Yeah.
And we're trying to push for like dash dash and then more descriptive name. So that's why. I'm not sure there is a long version of the dash FCT because I'm not sure how long ago that was, but
It's custom transform or something like that.
oh, it's dash dash custom transform. Okay. So yeah. Okay. How much time do I have? 10 minutes. Oh man, there's so much more. So this is someone writing their own aspect, but I wrote an aspect that is already in core Chisel you can use. Okay. There are dragons here. Watch out. But it's I would say on the scale of like least powerful to most powerful aspects, it is in the most powerful aspect. So you can do crazy things, but probably shouldn't, unless you really should. Okay. So it's called the injecting aspect. What I did, or what the API is given the top level of design, pick a sequence of modules that you care about, that you want to inject code into. Okay? Then given, this will be applied in sequence to each one of these modules. In this module, write Chisel code. This will then get injected into that design, okay? So imagine I imported GCD, trying to tape it out, and I need to do my ECO, okay? I need just a little tiny fix. Oh man, do I have to like clone the thing, do the stuff, and make my own like tape out custom thing? No, I can write this aspect. It's self-contained. It just does my little snippet of code, and it gets injected in. So how does this work? Same way all the other aspects work. We elaborate this Chisel, okay, and we get Fertile out, but we stick that Fertile AST in an annotation. That gets compiled with the rest of the Chisel. I guess I can show you this. Injecting, it creates a run Fertile transform annotation, which you've seen. So it says run this injecting transform and generate a bunch of inject statements, which contain the elaborated Fertile. Okay? What this transform does, where is it? All it does is basically find the inject statement annotation and basically append it to the end of the module. And then it relies on the last connect semantics of Chisel to let you do override things. Okay? But you get all the niceties of Chisel, of being able to write type-safe code. Let's see, where is it? Yeah. here I'm like directly referencing this output valid. So here I'm doing some bad stuff, right? I'm just saying output is always valid. It's getting stitched in at the fertile layer and assigning it to always be valid. And yeah. So this is where the, I said there be dragons. Like you don't want this to be the generic way you write code. Like, but in the cases where you are trying to reuse code that someone else wrote and you're trying to do some specialization, I mean, the other thing I can do is in this, I can actually annotate stuff. So I could do GCD. Oh wait, well, I guess I can show you this working before I got rid of that. So here we're going to add GCD injection. So we're going to run, and if you look at GCD, the output is always valid. Yeah?
Could you use this to like take a design and make all of it synchronous reset async?
Great question. Maybe. The caveat is the way we implemented asynchronous reset is with an abstract reset type, which has two concrete subtypes, the Boolean and the async reset, and we do this inference for you. So I'm not sure exactly how it would work, but maybe. But I'm glad you asked that because there's a few more things that I can show. The first is, in this aspect, there's something called, that I wrote called the select object, which is supposed to be used in this context, which lets you actually programmatically select things. So instead of by name, you can select things by kind or by type. So here, I'm going to select all registers of GCD. And so maybe not here. Let's do it here. So instead of me directly selecting them, I'm going to programmatically select all of the registers that are inside this module. And now let's see if that works. So it's the GCD mark signals. And there you go, I found both registers. If GCD has children, like it has children modules, maybe I want to programmatically iterate over all of those. So there's a function called collect deep, and you pass it in the top module, and then you give a partial function where basically it's saying walk all the instance hierarchy of top, and for each time you see an instance, call this function on it. So this is basically an instance, some instance in the design. Here, if I want, I can match specifically. So if I wanted to be like just type of GCD, I could do that. Or if I want to generically do it, say a raw module, and then do stuff. So I don't know, for each instance, I'm going to all registers of that. So if I do this, this gives me all registers in the design. I have a handle to them. And now I could, you know, registers, oh, it's an iterable of seek, so I have to flat map. And then, well, whatever, we'll reduce. Should think about that more than I'm comfortable live. Does that not work? Dot reduce. No, wait.
Can you just do flat?
Oh, yeah. Good call. Okay, so now I have all the registers in the design, and I'm going to map mark my function on. Oh, I have to import it. Oh, for each. Oh, I'm doing this in mark to print aspect. I should be doing this in here, in my injection, we'll say. So now what this lets me do is iterate over all instances, find all registers, and then mark them. And I can mix this in my command line without changing any source code, and print out all the source locations of every register in this line. Okay? Yeah.
Maybe you, on the offer, you show what it's about, right? Because you might have different type of mask for installation or other data types. So now from the offer, you can retail, right? What is it about?
Yeah, so let's say I did registers, but then I wanted to filter them. And I only want to see ones that are of type UN. I have, since this is an actual reference to the Chisel thing, I can look at the type. Or I could do uint if u.width known. Only select registers whose widths are known. Right? I can write really powerful programmatic ways to iterate over my design and pull things out and annotate, and then I create my custom transforms that consume those annotations and do whatever I want. So that's that. So this is in Chisel upstreamed, and you can use it.
So a quick question.
Yeah.
Is it, when you, back when you were defining output valid and true, it looked like it called elaborating design, like it called it try but don't execute thing twice. Is that actually what happened?
Yeah, so in this injection code, it calls a separate Chisel elaboration of just this code.
Okay. So Chisel, so we read in the first design into Fertile, and then it produces some Fertile, and then we read in the injected stuff, and it produces more Fertile, and then like stitch them together. Is that?
Effectively, the ordering is slightly different.
Okay.
The order is, I elaborate Chisel to create, and I create like the sort of, it's not actually Fertile, but it's some representation that will eventually become Fertile, and the elaborated design, which is like GCD, the class GCD that got instantiated. And then I run this aspect, and I create the annotations. And then Fertile happens, so then this thing got converted to Fertile. And then this is in an annotation, it goes, and then it gets stitched in, and then, yeah. Effectively, yes. Let me just say yes to that answer. Yeah. So the plan is to, I sort of want to open this up, and you can see how you can write your own little libraries that interact with stuff. You don't really need to, you can still do a lot of powerful things without really knowing Fertile, without really knowing the internals of Chisel. If you just stick by these APIs, things can get injected in and work. So with that, I think my time's up. So I also don't know who's next. Who's next? You guys are next. I turn it over to Shipyard. Thanks, everyone.
Thank you.